Hi, and thank you for clicking on the NeuVector security policy automation for zero-trust segmentation and zero-day attack prevention. Yes, that is a mouthful of buzzwords. My name is Tracy Walker, and I am here to help you sort out the marketing from the reality. We're going to talk a little bit about zero-trust segmentation and how NeuVector implements zero-trust that allows you to block zero-day attacks as well as any CVEs or vulnerabilities that you're unable to patch. With that, let's get started. What is zero trust? Well, zero trust broadly is a collection of concepts or an approach to validating or verifying. You can think of it as trust but verify. Not really. It's more complete than that. We verify everything. We don't trust anything. When I think of some of the analogies that you can use for zero trust, I often think of data center security. In high security data centers, you can't even drive into the parking lot without going through a gate where they check your ID, they check that you're on the list, and then they allow you in. If you have anybody in the car with you, they check their ID as well. If they're not on the list, they don't go through the gate. They have to sit outside. They don't provide benches, by the way. So anyone who goes in through the gate is known and anticipated. We have zero trust. When you go into the building, you enter a man trap where a door locks behind you and the door in front of you is then allowed to open. Again, zero trust. Only that one person can come in. When that person comes in, the security guard verifies again. Do you have an ID? Are you on the list of accepted visitors, etc., etc.? Are you allowed to go to that one cage? There's biometric readers that then scan the finger or the eyeball of the person who's visiting that particular cage, right? Multiple layers of security, all verifying the same thing over and over. Every time that person asks for access, they're verified. So zero trust in NeuVector is very much the same way. What we're doing with zero trust in NeuVector is, and I'll just take you to this group section, is we are creating rules based on behavior that we have seen. So for example, if I look at the process profile rules for this container that's running in this cluster, you can see down here all of these processes that have been seen running on this container. If I change to a different container, we see different processes. If I go to, say, this container, we see different processes. So you can see everything that the container is doing from a process standpoint as well as a network standpoint. Every network connection that we identify, and this is through our deep packet inspection, we identify and validate the layer 7 protocol. You can see there the applications, that is the layer 7 protocol. Ports are layer 3, layer 4. So we can work on any port as long as the protocol is Redis, and we can validate it as being a Redis protocol. So now let's show how we learn those behaviors. So this container right here, you'll notice doesn't have any network rules, doesn't have any process rules, and is running, if I just bring my browser down just a little bit, this container is running this little website right here. So this is a demo we frequently use. Basically, when I move this container to discover modes, we have 3 different modes. There is the discover mode, there's the monitor, and protect. So discover mode means we're going to learn the behaviors. So when I move this container to the discover mode, so let's switch our mode here, and I'm leaving it in basic. We also have a zero drift function that came in 5.0. The zero drift just basically means we don't need to use the discover mode. We can basically learn whatever is on the container itself, all the binaries that can execute. We will use those as our allow list. So in this basic discover mode, what we're going to do is we're going to learn behaviors of this container that's running. And the way we learn that is when we're exercising the container. So let's see, we've got OB1, is it 1? We don't know, but we're going to do it with OB1 and we're going to give OB1 an amount. We're going to submit that, and that's not, oh, you know what? That's not right. It's OB1 maybe that's not right either, but we don't care. But all we're doing is exercising the application. Let's go back to NeuVector, and I'll hit refresh in the top right corner, and you can see we've got network traffic. That's HTTP traffic that we're identifying there. And we've seen Java and POS. Java is the application that's running in Apache Tomcat, and POS is a Kubernetes process. Now, let's assume for a second that if I were going to, say, bash into this container, so I'll bash into this container real quick, and we'll run some other commands. First command I always like to run is who am I, to show that I'm running this as root. So I should be all powerful. I can be able to run lots of different commands. Let's ping some Oracle. So we've got some DNS traffic using some TCP ping. And as we're doing this, and I come back over here, I can hit refresh, and I'll raise this up just a little bit, and you can see we have now learned that bash and that disk usage and the ls, everything that I was doing right there. So we've added these security rules automatically to our allow list. You can see these are all allowed functions. So now for a moment, let's just change this policy to monitor. Sorry, I keep hitting the export. That's export is if you would like to export the policies. Switch mode is if you would like to switch the operational mode. So we'll switch to monitor mode, which means we will now establish zero trust, and we will now have alerts. We're only going to alert if any of these things happen. But what I'm going to do is delete the processes that I generated as a result of me being bashed into that container. So I'm going to delete those. So we're back to our Java. I think we did learn the additional traffic. So that ping that I did created that additional network traffic there. I won't worry about that for now. Let's just kind of focus on the processes. We're in monitor mode. And what that means is that in monitor mode, you can see that ping is still working. So if I did an ls and a who am I, and let's see what else did we do. We did a disk usage. So all of those things are going to generate alerts in NeuVector. And the reason they're generating alerts, and the reason I'm going to the wrong place, sorry, that was the vulnerabilities, there they are. See the ls and the who am I and the du. So these things that are happening, we're being alerted because these are outside of our zero trust, right? These things are riding in the car with me as I'm going through the gate. So we don't allow them to come through the gate because they are not on the list. So that's why that's happening. Now, what if I was not in monitor, but I was actually in a protect mode? Let's try that and see what that looks like. So who am I? Root. Should be able to run any, not permitted. Du, not permitted. Now I did this really fast. Who am I? Not permitted. Interesting. Ping. Right? I even had a rule that said it allowed me to use that network traffic egress to oracle.com, but that's not permitted. What about something else we haven't even tried, like a remove, recursive force everything in the container? Not permitted. So that again, zero trust. In the protect mode, we can block things in real time. And so in this case, if I come back here and I hit refresh, now you see we've got denies happening because we're blocking those things. Those commands that I was just doing are now causing alerts saying, no, we stopped those things from happening. Again, that's what zero trust is. That's what we're establishing. The way that this can become extremely useful is if we wanted to take those rules that we just learned and we were to, well, we'll just grab a couple of these then, right? We're going to grab 2 or 3 of these. We just created these rules. We can export these rules in a file, and here is that file. So this YAML file contains all of those rules, right? It's a custom resource definition within Kubernetes. And as I scroll down here, you can see application behavior. You can see there's some file or a section for the file protection, network ingress, processes that we're allowing on this particular container. So you're getting full process, network, and file access protection, ingresses, egresses, any of those kind of rules we can put in this file. export this and then replicate our zero trust across a lot of different clusters. You can even apply this to a cluster and compare behaviors, because if you apply it through a kubectl command, like an apply -f with this file, you'll actually get a comparison between different environments, and that can also be very helpful. So hopefully this was informative and helped you understand how NeuVector implements zero trust. How does this block 0 days? Well, a 0 day is not going to have processes that look like this. The processes that a 0 day is going to have are going to look different. It's going to have different network rules or different network connections, right? We don't want to have rules for it, but so any processes, network activity that is not of what we have known, again, zero trust, separating the known from the unknown. So if a CVE, a 0 day attack, that is going to be a combination of network connections and processes being executed that we have not seen before because it's an exploit. Same thing with an unpatched CVE. We're not looking for how this CVE could be could be exploited. It's the same as a 0 day. It's going to try to use network and processes that are not normal to your application behavior. And we know your application behavior because we have these network rules and process rules. So that's how NeuVector is able to lock down a Kubernetes cluster using zero trust segmentation at network, process, and file access levels. We're able to establish that zero trust. Anything that we don't trust has to sit outside the gate and doesn't get allowed in. Hope you're enjoying your SUSECON 2022. Again, my name is Tracy Walker. I'm a solution engineer with SUSE NeuVector. We hope to talk to you soon. Thank you.